Has to migrate the graphical applications of those systems to Eclipse RCP. And we are here to talk to you about the adoption of Eclipse RCP to build rich graphical applications for the space domain. I would like to outline the main points from our talk. We will start by giving you an overview of the migratory systems to understand the GUI goals and requirements. After that, we will focus on the technical approach. In the next section, we will discuss the main challenge that we have found during the migration. And finally, we will talk about the future developments, and to sum it up, we will draw our conclusions. Then let's start with the overview of the migratory systems. As I have said before, GMB developed several systems for the space domain, but GMB only is migrating 3 of those systems: the satellite control system, the flight landing system, and the mission planning system. The satellite control system is in charge of monitoring and controlling the satellite. It receives information from the satellite about the status of the satellite and set operations to the satellite to control the satellite. The GMB product is HiFlight. The flight landing system is responsible for calculating the position of the satellite. It uses the information received from the satellite to calculate the position. And the GMB's product is called Focus. And the mission planning system is in charge of planning the satellite operations. Then the user entering the system, the satellite operation, the system calculates when the operation can be sent to the satellite, and this system provides this plan to the satellite control system, which finally sends the operations to the satellite. Then we have 3 very different systems. I will describe in more detail some technical details about this system. These 3 systems are based on a client-server architecture. In the case of the satellite control system, the server is implemented in C++, and the client side is implemented in C++ and I Love Views. I Love Views is a graphical toolkit to implement C++ graphical applications. The communication is based on Corva and TCP/IP. The applications of these systems are basically real-time applications that receive the information of the satellite, process this information, and represent the information in several ways, for example, as charts. The flight landing system has a TCL server and a TCL-TK graphical application. The communication is based on TCP/IP. In this case, the applications are offline applications. The operator configures and executes some kind of programs to calculate the position of the satellite from the application, and this application represents the results of those programs in several ways. For example, as standard outputs, as table, as charts, whatever. Here we have an example of a 3D application where we can see the satellite surrounding the Earth. And finally, the mission planning system has a C++ backend, and the graphical applications are implemented in C++ and I Love You. The communication is based on Corva. And in this case, it's also offline applications where the user enters the operations and a period of time to be sent to a period of time when the operation has to be sent to the satellite. In this case, the system calculates the plan and represents the plan in a Gantt chart. Then let's start with the GMB goals. The first goal was to replace the presentation layer to remove the dependencies with TCL-TK and with I Love Views. We wanted to replace the presentation layer, but we want to reuse the system business logic. We have seen that we have 3 different systems with different origins, and the applications were very different. Then we wanted to harmonize these applications to allow GMB to offer a single product for the space domain, for the ground segment. We also wanted to improve the usability of these applications. If these applications are similar, these are more usable for users that have to use applications from the 3 different systems. And of course, we want to improve the maintainability. We have there were a lot of common components in the 3 systems, and these components were implemented in the 3 different systems. Okay, and the requirements. These systems are operational systems, and they demand very good performance because they process real-time information. Another feature of these systems are generic systems, and but each space mission and each satellite has a specific requirements. Then we need to extend our system and configure the systems to meet the specific requirements for each mission or each type of satellite. And another way of configurability is that the user needs to configure the information they want to visualize in the application and how they want to represent this information. Of course, the application has to be multi-platform unless they have to run in Windows or Linux. And we wanted to use an advanced development environment. For example, for DCLTK and C++ and iCompute, we didn't have an advanced development environment, and we have to use V or something like that. Then we wanted an advanced development environment with an advanced IDE like Eclipse, a build system that allows us to execute automatically the compilation of the systems, the execution of the test, and the checks of the code. And a continuous integration system to execute the build system periodically to detect as soon as possible the implementation problems. And why we select Eclipse RCP? Because it is platform independent and allows us to implement applications with a native look and feel. Eclipse RCP is not only a graphical toolkit. In fact, Eclipse RCP is based on SWT and JFace as graphical toolkit, but Eclipse RCP is based on OSGI, and OSGI allows us to implement modular applications. And that guy has explained this morning the advantage of OSGI, then the same advantage for us. Eclipse RCP also provides a lot of features, the same features that we can find in the Eclipse IDE. We can reuse this feature for our applications. And Eclipse RCP also defines a new type of relationship, the extension point, that allows us to extend the functionality of a component without coupling the two components. Eclipse RCP is widely supported by an active community and the industry. And one of the most important reasons was the last one. GMB also collaborated in the development of some ground system infrastructure for the European Space Agency. And when GMB decided to migrate their systems, the European Space Agency started the migration of their infrastructure to Eclipse RCP, and for GMB it was very important to be aligned with the technologies of the ESA. Okay, then now I will explain our technical approach. We have three different systems that interchange some kind of information between them. And the first thing what we did was to move all the business logic to the backend systems to enclose as much as possible the scope of the systems. After that, we remove all the presentation layer and create a new layer to encapsulate the communication details. And at the top of this layer, we create the new graphical applications which are based on the same technology, and they share some common components. Then in this view we can see the architecture of the new applications. We have the backends, and the communication is based on a middleware, and the graphical applications consist of two layers, the service layer and the display layer. These two layers are implemented in Java and Eclipse RCP. Now we will detail these two layers. The service layer decouples the presentation layer and the business logic, and communicate with the backend by means of the middleware. This service layer defines a new concept for us, the concept of service, which is a software element in the backend that exposes the functionality of the backend. and the service adapter. The service adapter is a software element in the service layer. It's like a proxy that allows us to access to the functionality in the backend, but it's just a proxy. It doesn't implement any additional business logic, and it's implemented in Java, and don't depend on any graphical element, and it doesn't depend on any Eclipse API. This layer also provides a mechanism to consume service in a transparent way. The application doesn't care about the implementation of the service adapters. This opens to us two new options. We can replace the middleware for a different middleware. For example, if we have a Corba middleware, we can replace this middleware for a message-oriented middleware. In this case, we only need to replace the service adapters layer, the service adapters, for a new implementation of the service adapter. But we don't have to modify any graphical element. And the second option is to expose the functionality of the backend via another kind of application, for example, a web application. In this case, we can wrap the service adapters with web services and implement the new graphical application. In this case, the web application will access to the functionality via the new web services. And the display layer implements all the graphical elements that allow the user to access to the functionality of the backend. We have identified two ways to implement reusable components. Reusable components at functional level and reusable components at widget level. Then here we have the display. A display for us is a graphical element that visualizes some information and allows the user to manipulate some information. This allows the user to access to some functionality of the backend via the service adapters. A display for us is implemented as an Eclipse build. For us, an application is just a display container. And this application also provides a mechanism to save and restore the status of the application. This mechanism is based on the Eclipse memento. For example, this is an advantage of using Eclipse RCP. GMB also defines some graphical guidelines to harmonize all the displays that we develop. These guidelines define the common look and feel that the application has to have, and these guidelines, for example, establish the set of icons that we have to use in our applications and the set of colors that we have to use. These guidelines also define the structure of the application. For example, an application has a status line where we can see the connection status of the service adapters and some kind of log information. An application also has a set of displays. In this case, we have only one display, and a display hub has an action area where the user can execute all the main actions in the display, and also a working area. The working area depends on the type of display. These guidelines also define a uniform interaction paradigm to improve the usability of the applications. We also define some common widgets, because we detected that the applications from the three different systems use the same type of widgets, but JFace and LWT don't provide this kind of widgets. These are examples of the widgets that we have implemented. In some cases, we have to use a third-party tools. For example, in the case of the Gantt chart, this Gantt chart is based on the Gantt chart of Nebula. Nebula is an Eclipse project that provides some advanced widgets, and this is one of them. And in the case of the chart, we have used a JFree chart. And then now I will explain how to create new applications with this infrastructure. Then we immediately have a backend with some services exposing some system functionality. And the first step is to define the new services to expose the new functionality that we want to manage. After that, we have to create the service layer. In the service layer, we have to define the service adapters that we need to access to the backend functionality. Then we can reuse some existing service adapters, and we need to implement new service adapters to access to the new functionality. After that, we have to define the display layer. In the display layer, we can reuse some existing displays that access to the existing functionality, but we have to implement new displays that use the new service adapter to access to the new functionality, but we can also reuse some existing service adapters. And then we already have our graphical application. Then the result of the migration are these. This is an example of satellite control system application. This is an example of the plugin and system application with the program configuration and the results of the program. An example of the mission planning application with the Gantt chart, and another example of the plugin and application with the same Gantt chart. And now my colleague will continue with the main challenge.
Well, we have seen in this first part, we had different products in the ground segment and that we decided to integrate the graphical user interface to Eclipse RCP. We have seen it from the point of view of the common architecture that we define in order to do this. And this section is more focused on how we create a common development environment that supports this concept. The first step, and it's probably the most important of them, was the definition of a target platform for the common development. Target platform is basically a set of plugins that you intend to reuse among different developers. We noticed that we have different systems, we say, that's file control system, file dynamics, mission plan. They share common functionality among them. So our first step was to identify the set of components that were common among all of them. And with this information, we created the plugins that were part of the ground segment target platform, and it was shared among the developers. So basically, we have a ground segment target platform for other systems with this common set of plugins, the Eclipse RCP plugins, and other third-party products. But this was just the first step we made. We also noticed that we have another kind of functionality that was common among the systems of the ground segment, not maybe for all the ground segment. So we decided to create different set of target platforms, one of them for each kind of system inside the ground segment. So we have a satellite control system target platform, a mission planning target platform, and a file dynamic target platform. So in our hierarchy of plugins for ID development, we have the plugins that are common to the whole ground segment and the plugins that are specific to a system in the ground segment. Obviously, handling all this information can be quite difficult because we have different versions of the plugins evolve in time when you fix a bug, when you introduce a new functionality. So for developers, it can be quite difficult to know which set of version of plugins you need to use for specific development for specific products. So we decided to make use of the idea of target definition. In an Eclipse development environment, the target definition is basically a reference to the set of plugins you have to use for development. So a target definition is references the concrete version of the plugins that the developer has to use for specific development. This target definition is a set of file that you can use in your ID and references the version of the plugins. We understand it as a configuration item for the new developer. We see it in the new section. We decided to create a common development environment based on Eclipse for all the developers to share the same infrastructure of development. And the target definition is probably the most important item of all of them because they need to set at the beginning of a new development a reference to the plugin they need to use for a specific product. We also decided to create for the development a common set of coding rules in order to share a same coding style. We have defined codification rules that are checked with check style in your Eclipse environment. We have also files defining the formatting of our code that all the developers have to use in order to harmonize the same coding style. We apply the same data policies, and all this information is checked for instance, with Sona, probably you know Sona, which inspects in our continuous integration system how our code is evolving, the violations that are being raised, and we use it to check that all the developers are following the common set of qualification rules. So basically we have set a common data platform infrastructure, we have a common development environment. We also decided to create a common build system. Building large applications like this one can be very difficult. They have a lot of components, some of them of different languages. And one of our first commitments was to create a common build system that could be reused among the different products. In our beginnings, we had shell scripts, which were Python or C# based. And our first attempt was to create an end-based build system that could be reused for the different products and that finally makes use of the PDF Eclipse development environment. This has been used for years. Now we're in the process of moving this to a Maven typo-based development environment. We think that Maven fits better in our idea of how we build our application, and it fits better in our continuous integration system, thinking our hats on. And in a short future, we intend to move all these infrastructure target platforms of common set plugins to a Nexus repository. Nexus is a technology to handle artifacts for different development. And our idea is to compile all our applications against this Nexus repository, where we are going to store all this set of common plugins for different products. This section maybe is not related with the development environment system, but it's more with the actual operation of the application. An issue we had when adopting RCP, and it's quite important for us, is some issues related to the SWT infrastructure, especially regarding the performance problems that we experience. We have some displays that need to represent lots of information, for instance, parameters in real time with a high refresh rates. And we first adopt SWT as the technology to present this. We noticed that it had serious performance problems. So, especially when we have high refresh rates of the information. And our only solution for this was to make use of swing to display the information. So in our display, so in real time, when they require high refresh rates, we have bridge between SWT and swing to do this, which is not a very good solution because it had a lot of bugs that we have to fix during this process. And finally, regarding the SWT, it's maybe a minor issue. We found, as also said, that sometimes you lack of advanced widgets if you want to represent complex information. And a sample of these is the Gantt charts for presenting events in time. For years, our only alternative here has been the use of the Nebula Gantt chart. It's a widget on the Nebula project. It has been developed for years, and now we are considering to move to another technology, GUI. But in general, our idea here is that you maybe lack of advanced components when you want to represent complex information, and most of the time you have to develop it. This first part has been regarding the common development environment that we set, and this last part of the presentation is focused on the future of how we see the evolution of our products in a close future. The most important thing to consider in the close future is related to the adoption of Eclipse 4. Currently, our application are based on Eclipse 3 point something, and we are considering the integration to Eclipse 4. It's a complex decision because it may have an impact in all our structure of common set plugins, the common functionality, and we're considering carefully how to do this. We have several alternatives. For the moment, we're just going to develop new application only in Eclipse 4 and see how this impacts in reducing the common set of plugins that we have based on Eclipse 3 point something. And another important issue to consider in the future is the adoption of Eclipse Wrap for clients that are web-based. We have seen that our clients are demanding more clients that are web-based. So we think that RAP is probably the best technology to do this. In theory, you can have the same code that you develop for Eclipse RCP, and you can have this in both RCP and RAP. We are considering to migrating some products to Eclipse RAP, or starting new developments that are only based on Eclipse RAP and using the backend that we already have. We also are experiencing some more demanding applications that require 3D models, for instance, and for which we don't have a common approach. An example of this is the display of planets. For instance, when you want to display the highest light in a planet, or you want to have a view of a moon or Mars. Currently, we have a solution that is based on OpenGL, and we are considering using it and expand it in order to support WT. And we are also considering other solutions. For instance, NASA Whirlwind is a SDK that allows you to represent the Earth and some planets. For this, we have to consider which is better for new developments. Another important technology that is required lately is the EIA phase, and also we have a common approach for other projects. So we are sometimes we require, for instance, recent information over maps. These are some examples. We sometimes need to represent the rover, the path for rover on Mars, or represent satellite information from scientists. At this moment, we're evaluating this technology. UD is a Eclipse plugin that allows you to represent, to manipulate EIA-based data. It has a limitation that is only 2D based. And we are also considering here adopting the NASA Whirlwind for GIS when 3D is required in the applications, because NASA supports 3D. But in fact, we have many alternatives in order to do this, so probably we are going to choose the one as the baseline for the development that GIS based. And finally, some conclusion of this process adoption. The first one is probably the most important. Is for us, we think RCP has been a very, very good choice for the client representation, for the user interfaces. It allows you to build modular applications. It's especially good if you had, like we had, the application with different components you want to reuse, you want to produce specific products for some context. Our clients are pretty satisfied with the change, with adoption. At that point, maybe that the migration of existing products can be complex, especially if your products are operational, and you have to focus very carefully creating a common infrastructure to do this, because otherwise it can be very difficult. But on the other hand, the results are very extensible and configurable. You can create different configuration of products, for instance, for a specific mission, sharing almost the same infrastructure of them. We think that a good look at it that can be portable on different platforms, though it has some Linux Windows mismatches that you have to consider, especially some widgets do not behave the same way in different platforms. Maybe a good point is that we have experienced a steep learning curve for our teams, especially if you have teams that come from very different profiles, from very different codification languages. But on the other hand, it has a very active community, a supporting industry. In our case, it's the European Space Agency which support this technology. And to conclude, some minor issues regarding WT, which are the most important one in our industry, has been the performance problem that we experience on development graphical applications in real time. And maybe that we found it lacks a bit of advanced widget for creating some complex displays or some complex information. So basically, this is all. Time. Do you have a question for this? No, sure.
So, how did you manage the service layer with Corba? Did you wrap the C++ application, or you use Jack ORB or this kind of thing?
So how do you manage to communicate to Corba?
Yeah, you have formerly Corba,
Yes.
and then you wrap it in a service adapter.
Yes.
So
Well,
it's on the RCP interface, you wrap the Corba, and then communicate with Corba.
Yes.
Okay.
Yes.
And you wrap the C++ Corba or use a native Java script?
The backend is developed in C++. We have an ADL exposing those services, and the service layer is written in Java. So we can communicate because we have the same IDL for the communication of the both C++ based on Corba and the Java layer.
Okay.
They both have the IDL interface and the